This is Eric Peter. I'm a PM at Databricks, and I look after our GenAI quality offerings. Today, I wanted to walk through a quick demonstration of how you can use our GenAI quality features to help you monitor and improve your production application's quality. Before I dive in, call out some of the challenges that we've heard from our customers. Overall, it's really hard to deliver ROI with GenAI. Is my application consistently producing high quality, accurate responses? How do I monitor that nothing has actually slipped past my guardrails? And how do I know if my GenAI app is consistently fast and cost effective? We've invested significantly in our evaluation tools that help you build high quality GenAI applications, both iterating during development and monitoring them in production. We've packaged all these capabilities into a set of tools that give you unified observability across all your GenAI applications. You can evaluate, monitor, and improve every use case, no matter where it's deployed. If it's deployed on Databricks, if it's deployed in your cloud environment, we can help you monitor and evaluate that application. At the core of our capabilities is ML flow tracing. It's our open source standard for GenAI observability built on top of OpenTelemetry. You instrument your application with ML flow tracing with just one line of code, and we're able to automatically extract out all the relevant information that you need to evaluate and monitor that application. You can monitor it using Lakehouse monitoring, and you can test it during development with agent evaluation. Let's walk through the workflow, and as I do this, I'll demo these capabilities in an application that I've built. The application that I've built, it's a simple agent that helps users of a retailer's website get help troubleshooting their product issues to try and avoid returns. So this application, I've deployed it to my end users. I've instrumented it using ML flow tracing and OpenTelemetry, and it's feeding ML flow traces into my Unity catalog so that I can do monitoring.
Before I show you the application's code, let's go ahead and enable monitoring. Here, I'll go into my MLflow experiment, go to the monitoring tab, and I'll choose external since my application is hosted off Databricks. I'll give it a Unity catalog schema where the logs will be stored. Next, I'll enable our built-in judges to check the quality of the application. I can customize these judges with plain language guidelines that define how my application should respond. I'll set the sampling rate. In this case, I'll set it to 10%, and I'll go ahead and create the monitor.
Let's quickly take a look at the application and how I instrumented it. You can see here, I imported MLflow. I used one line of code to set up the automatic logging, and I've told MLflow to pass the traces into the Databricks environment. So let's go ahead and take a look at that application. Now, let's go ahead and ask the application a question. My office chair won't reply. We see it's thinking, it's doing some research, and it's going to go ahead and read these results and give me an answer. Let's go ahead and look at our live monitoring dashboard. Here, I'll hit refresh, and I can see I'm immediately seeing this question that I asked. In here, I can take a look at exactly what's happening. I can see the message, I can see the model's output, and I can take a look at the documents that were retrieved to help answer this. If I need more detail, I can come in to the full ML flow trace, and I can go ahead and look at the calls to the LLM. I can see the system prompt. I can look again at exactly what query was issued to the vector store and how the LLM used that information to respond. Now that I've seen one response here, let's go ahead and look overall at my application's performance. It's only been in production for a little bit here, but I'm already starting to see some significant usage. And coming down here, I can take a look at the various different metrics that we're running. These metrics are based on Databricks proprietary LLM judges, which are easily customized for your business use case. So in this case, I've got a question, a judge to understand if the answer is relevant. I have a customized LLM judge to make sure that the bot never actually gives pricing information. We can see we're actually doing pretty well on this. So, however, if I take a look here, I can see that my chunk relevance and my groundedness, the bot seems to be hallucinating a lot. And frankly, it's not finding relevant information from the vector store. So I'll need to dig into those issues. Before I do that, I'll just take a quick look at some of these operational metrics. I'm seeing about a 6-second average latency, which isn't awesome, but I'll come back to that later. And I'm seeing about 4,500 tokens or so on average. Luckily, there are no errors in the application. So let's come back over here to the logs. And let's go ahead and look at those ones that are failing and not grounded. Now, for the purpose of this demo, I won't spend a lot of time going through these questions. I did so offline, and what I realized was that there's a theme among these questions. So I was able to see, a lot of the time, of course, the judge was saying that the answer is not relevant. Each of the documents that were retrieved were not relevant, and more often than not, it was not grounded. What I realized actually is there's a common theme across all of these questions where it's failing. These are all kitchen products. And I went and I looked at my vector store and I realized I made a mistake. I forgot to include the kitchen documentation in this bot. So I need to go ahead and fix that. What I'll do here is I'll choose some of these logs. I'll take a look at these logs. And what I really want to do here is I want to use these logs to go and test if putting all this documentation in helps fix these problems. So I'll take these questions, these production logs, I'll go ahead and I'll hit export traces. Now, in export traces, I can do one of two things. I can export these to an evaluation data set that I can use in my development loop to go and test if my fix, adding new documents to the vector store, actually worked. I could also go ahead, in this case, if I needed to, I could send them to a domain expert for labeling. So let me quickly show you what it looks like when I send these to a domain expert. The domain expert will get an application that looks like this. They'll be able to see what questions were asked. They'll be able to see what the assistant actually responded with, as well as the various different documentation articles. They can provide me input like what facts should have been responded with here. I can customize these questions to help understand and collect feedback from these subject matter experts. In this case, I'm pretty confident that the problem is that I missed these docs, but let me go ahead and check. So what I did previously, I mentioned, I kind of exported these to an evaluation data set. So I've got that evaluation data set up here in a Databricks notebook. What I'm going to do here is I'm going to activate Agent Evaluation's inner loop capabilities through MLflow. I'm going to first pass in the first version of my agent just to make sure it wasn't a fluke. And I'll pass in that evaluation set here. I'll turn on a few custom metrics that I've written. So looking at, is the agent grounded in tool outputs? Is the answer relevant? So on and so forth. These are actually pieces of custom Python code that I wrote. I'll also turn on some of those built-in LLM judges, the chunk relevance, guideline adherence, and groundedness. I've run this, so let's go ahead and take a look at these results. Here, I can confirm, yes, indeed, I'm failing. So this is definitely still an issue. It wasn't just a fluke online. Now, you'll notice this UI here that I'm using for my inner loop is remarkably similar to what I was looking at for my production monitoring. That's intentional. We've unified the online and offline experience, and the same metrics and the same user experience apply to online and offline. The difference in the offline world, what I can actually do is I will come down here and I will run an evaluation on my version 2 of my agent. So I've added the docs into the vector store here. Let's go ahead and open that. Now, I can see I'm doing a lot better, but let's just go ahead and compare to that first version. Now, this is the key difference between online and offline. In offline, I'm able to compare between two iterations to see if I made an improvement successfully. In this case, I did increase by 78%, which is really good. But I can see here, I flipped most of these questions from failing to passing. I can dig into the reasons of why I did that. Um, but I can also see here, there's actually a few that kept failing. So maybe I'll actually open this one up and let's see. So in this case, the first answer, um, couldn't find any information. But the problem here is that it looks like it is able to find some information. But so what's actually going on here? Turns out that the response in this case is actually not grounded. So it's finding some additional information, but the LLM's hallucinating. So I'm going to need to do a little bit more work before I can deploy this to production. So coming back here, I can show you what we walked through. We deployed our GenAI application. I instrumented it with MLflow and OpenTelemetry. I was able to observe a problem for my production monitoring. I was able to take a handful of those MLflow traces and put them into my test suite or evaluation set. I could have gone and collected input from domain experts to really define what the standard of quality is here. And then I used that evaluation set or that test suite to iterate in development and make sure that I was able to fix the problem that I identified. And of course, I'm going to go ahead and deploy that new version. Thanks for watching.